Have you ever just looked at a really complex piece of metal, like an engine block or a high-end bicycle frame, and just thought, how in the world did they make that? It seems almost impossible, right? Well, today we're going to pull back that curtain and see exactly how these incredible objects are created. I mean, think about it for a second. A race car's frame has to take these immense forces, but it can't just be a solid block of steel. It'd be way too heavy. So how do engineers get that perfect, almost magical balance between brute strength and a lightweight design?
Well, it's not magic. The secret isn't one single technique. Instead, it's this brilliant collaboration between three fundamental ways of shaping metal. This trio, well, it's really the core of all modern manufacturing.
So here's our game plan. We're going to start with the big picture, the fabrication triad itself. Then we'll zoom in on machining for precision, forming for strength, and welding for unity. And finally, we'll see how they all come together in, well, a symphony of engineering. Okay, first up, let's get a handle on the triad itself. The best way to think about it is like a master builder's toolkit, right? You don't use a hammer for every single job. You've got specific tools for very specific tasks. And here it is. This table is basically the mental map for everything we're about to cover. Machining is all about subtracting material, kind of like a sculptor, to get incredible precision. Forming is about reshaping material, more like a blacksmith, to build in strength. And welding, that's for joining different pieces together to create unity. So just remember, subtract, reshape, join. That's the whole idea right there. Let's start with our sculptor, machining. This is the art of pure precision. So, at its heart, machining is a process of removal. You start with a bigger chunk of material and you just carefully cut away everything you don't need. What you're left with is the final perfect shape, often with an accuracy that's measured in thousands of a millimeter. It's wild. And this is done through operations you've probably heard of. You've got turning, which creates round parts like a shaft on a machine called a lathe. Then there's milling, which uses a spinning cutter to carve out really complex 3D shapes. And of course, drilling makes holes, and grinding gives you that ultra-smooth, polished surface finish. But here's the catch, the trade-off. Machining gives you this absolutely unmatched precision, which is amazing. The weakness, though, is that when you cut the metal, you're slicing right through its internal grain structure. Think of it like cutting wood against the grain. You can actually create points of weakness. So how do we get around that problem of a weakened grain structure? Well, that brings us to our second process, forming. This is the blacksmith's hammer, the science of creating strength. Forming is pretty much the total opposite of machining. Instead of removing material, you're just pushing it around. You're using incredible force through things like forging or stamping to basically squeeze the metal into the shape that you want. Now, what's so cool about this is what's happening inside the metal. Because you're squeezing and reshaping it, you're not cutting that grain structure. You're actually aligning it and compressing it. The grains literally flow along the shape of the part, and that makes it significantly tougher and way more resilient to stress. And look, this isn't just a tiny difference. As our source material points out, formed parts almost always beat machined parts when it comes to taking a hit or resisting failure over millions and millions of cycles. This is exactly why critical components, like an engine's crankshaft, are forged, not just carved out of a block of steel. Okay, so we have a way to make parts precise, and we have a way to make parts super strong, but how do we stick them all together to build something bigger? Well, that brings us to the third member of our triad, welding, the bond of unity. Welding does something pretty remarkable. It takes two or more totally separate pieces of metal, and by melting them right at the joint, it fuses them into a single continuous piece. And when it's done right, that weld can be just as strong as the original metal itself. But getting it right, that is a real art and a science. You've got to control the heat perfectly, you have to prep the joint meticulously, and you absolutely have to avoid tiny defects like pores or cracks that could grow under stress. Because, like our source says, any structure is only as strong as its weakest weld. All right, now we get to the most important part. We've looked at each instrument on its own. Now let's hear the symphony. Let's see how these processes work together in perfect harmony. See, the real takeaway here is that you don't just choose one process over the others. That's not how it works. You choose the right process for the right feature. They're not competitors at all, they're collaborators, and each one brings a totally unique skill to the table. So here's how that actually works in the real world. First, you might take a raw piece of steel and you forge it into a rough shape. Why? To get that amazing internal strength from the grain flow. Then, you take that super strong part and you machine only the specific areas that need to connect perfectly with something else, like bolt holes or surfaces for bearings. And finally, you weld that incredibly strong and precise component into the larger structure, like that race car frame we talked about. By combining this triad, engineers really get the best of all worlds. You get the brute strength from forming, the pinpoint precision from machining, and the unity from welding. The final result is this elegant system that's just perfectly optimized for whatever job it needs to do. So next time you're out and you look at a bridge or a skyscraper or even the chair you're sitting on, think about this triad. You now have this new lens to see all the hidden engineering that's all around you, that story of strength, precision, and unity that brought it into existence. So what are you going to see differently?